Good morning. I'm Prabh Singh, a B.Tech Construction Management student at BCIT, and today I'm presenting a comparative analysis of two ventilation retrofit options for King and Crescent Building C in South Surrey, a 72-unit building with significant air challenges. What happens when 72 families share air that doesn't move? You get overheated corridors, stagnant parkades, and odours traveling between units. Building C has a serious ventilation problem, and today I'll present two viable solutions to fix it. Here's our roadmap. I'll cover the building background and the specific ventilation issues. Then I'll compare our two retrofit options, central versus suite level, and close with the financial analysis and final recommendation. Building C is a four-story residential facility with 72 suites and underground parking. The existing ventilation relies on an outdated central corridor system. The core challenge is that the system doesn't deliver equal airflow to each zone, creating hot spots and stagnant pockets throughout the building. Specifically, residents are facing three issues. First, comfort. Upper corridors overheat while lower floors lack fresh air. Second, financial waste. The building is paying for insufficient operation. And third, safety. Stagnant air in the parkade creates odor and safety concerns. The root cause is unbalanced airflow and controls that lack necessary zoning. To address this, I've developed two construction options. With a $2 million budget, option 1 is a comprehensive central ventilation retrofit. Option 2 is a decentralized approach using suite-level HRVs. Option 1 is my recommended approach here. It is a significant retrofit of the central system. We would install dedicated outdoor systems with heat recovery, rebalance ductwork across all four floors, upgrade to variable speed motors with a building automation system. The estimated cost is $1.74 million with an 8 to 10 month summer schedule to minimize disruption. That 1.74 million covers the new DOAS units, 16 weeks of installation, labor, engineering. Crucially, according to research by Lozinski and Tochi, published in Indoor and Pressurized Corridor Systems, work best with the demand control ventilation included in this option. Option 2 is a distributed approach. Instead of central fix, we would install compact heat recovery ventilators in each of the 72 suites, plus parquet upgrades. While this allows for a phased floor-by-floor schedule, it requires accessing every single unit, a massive coordination challenge. The second option totals $1.84 million. The cost is driven by purchasing 72 individual units and the labor required to drill exterior wall penetrations for every apartment. The timeline also extends to 14 months due to the complexity of accessing private units. Now, for the financial comparison, option 1 is more efficient, offering 35% energy savings compared to 28% for option 2. But the real story is maintenance. Option 1 costs about 18,000 a year to run. Option 2 is nearly 47,000 because you're servicing 72 individual filters and motors. Over 20 years, option 1 saves the strata over $500,000 compared to option 2. For implementation, option 1 is less intrusive. Work is confined to mechanical rooms and corridors, so no suite access is required. Residents might experience temporary ventilation shutdowns, but their daily routines remain largely unaffected. Option 2 offers individual resident control, which is a benefit. However, the logistics are difficult. We need to coordinate entry into 72 private homes to drill through the building envelope, extending the disruption significantly. Side by side, the choice is clear. Option 1 wins on capital cost, it wins on energy savings, and it wins decisively on maintenance cost. Most importantly, the timeline is shorter. The 20-year savings of $530,000 represents massive value for the owners. The analysis is grounded in peer-reviewed research from journals including Indoor Air Building and Environment and the Journal of Building Engineering. Key studies by Berquist, Fine, and Tochi and Lozinski inform both the technical specifications and the feasibility assessment. The project aligns with the term project deliverables, with the final report due December 13th. I recommend proceeding with option 1, the central ventilation retrofit. It solves the root pressurization issues at the lowest cost with the least resident disruption. The next steps are to finalize the timeline, secure strata approval, and establish a monitoring plan to verify performance. Thank you for your time. This analysis demonstrates that we have a cost-effective solution to fix Building C's air quality for decades to come. I welcome any questions.